Okay, so my intent is to only make the videos about 10 minutes long, so obviously I've been failing in that attempt, but let's see if I can do better this time. Okay, so if this is Math 211, week 7, video, I guess we would be up to video 4? Yeah, I guess so. Okay, so it's your turn, and this video is going to be 4 examples. Okay, so I'm going to put an example on the screen, and then you should pause the video and do what you can with it, and then repeat for these 4 examples. Right, I might split it up into 2 videos. We'll see how the time goes. Okay, so find all the derivatives in graph. So this is a special question, find all derivatives in graph. But it didn't say you had to go through every single step in the process. It just says find all derivatives and graph. Always have to be very careful to read the instructions in a math exam. Okay, first derivative, 3x squared minus 4x plus 1. You guys have no trouble with this. This type of exam question nobody gets wrong. And the point is, etc. equals 0. Alright, so now we want to graph it. In order to graph it, so these are not broken down into roots very nicely. There is a nice way of factoring, but you probably don't know this, but I will tell you how it works just in case you want to know. If I factor out x squared, actually it doesn't quite work. If this guy were a 1, it will work beautifully. It's not going to work. Okay, x squared, we could say x minus 2, and then we have x minus 1, but unfortunately these guys don't match, so we can't make use of a specific grouping factoring trick that I was going to show you. Too bad. Okay, so let's do something else instead. Alright, so if y prime is equal to 0, when is it equal to 0? We use the quadratic formula, or we factor this thing. If you can see how it factors, that's great. It will factor, but let's pretend that you don't remember how to factor or your mind's on the fritz. Okay, so then you just say x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, 16 minus 12 would be about 4. Okay, so x is equal to 4 plus or minus 2 over 6, which is 2 plus or minus 1 over 3. Okay, so that splits up into 1, because if you follow the plus, 2 plus 1 is 3 over 3. 2 minus 1 is 1 over 3. So those are your 2 roots. Okay, so this is looking like a bit of a mess. Okay, so x equals 1 and 1/3 are critical points. And because I have an eraser, I'm just going to get rid of this because I think that's enough work to show. Alright, now over here, if I put x is 4 over 6, or rather 2/3, that's going to be a point of inflection. And what is this? This is a cubic. And so we have a special deal on cubics. Because it's a cubic, we don't have to test that these guys are critical points and that guy is a point of inflection. We can just label them. That's the only thing it could possibly be. But we do have to find the y values for all this stuff so that we can plot. Okay, so let's figure out what's going on. Well, this guy is easy. Y of 0 is negative 1. We may as well plot that one because it's just, see, look, whenever you have a polynomial, these guys are all 0. And then this little term, that's the y-intercept. Since it's so easy, we may as well just keep track of that. Alright, so what else do we have? We want y at 1 is 1 minus 2 plus 1 minus 1. What is it? Let's see. 1 minus 2, negative 1, plus 1 is 0, and then minus 1. So y at 1 is going to be negative 1. Okay. What about y at 1/3? But where am I going to write this information? Let's see. I'm having a hard time figuring out how to lay this out on the page, and I know that you guys have the same problem too. Y of 1 is equal to -1. There we go. Let's calculate y of 1/3. So we have 1/3 cubed minus 2 times 1/3 squared plus 1/3 minus 1. Alright, so that's a pain. You can use your calculator if you like. I don't care if it's just a numeric excuse me, approximation. That's totally fine by me. But I feel obligated to go ahead and do these fractions. Not really sure why. Minus 23 over 27. So if you calculated this by hand, you would end up showing that that's just a little bit larger than -1. Okay, so y of 1/3. I'm going to stretch these points out here. Let's see. This is kind of weird, huh? So there's 1/3, 2/3, and 3/3. That's roughly what we're talking about here. That's enough information for that. Now what? Now we go through the same slimy mess for y of 2/3. And you end up finding out that it's minus 25 over 27, or you go ahead and do something numerical with that. But the last one we had was minus 23 over 27. Okay, so if this is -1, it's actually, think of it this way, y of 3/3 is equal to minus 27 over 27. So these guys are right in a line like I promised you they would be. There we go. And this little point over here, I'm going to just make it a different color to indicate it's not a critical point. It's just an axis crossing to help us get our bearings. Okay, so this is just, this is a bad view on this thing. I'm trying to make it less bad. There we go. That turned out okay. So this is our min, this is our max, and this is our point of inflection. Okay, so I'm pretty happy with that plot. So that by the magic of using erasers and computers and moving things around on the screen, I could make it look less bad than it did, like the first time I tried it. Okay, I'm going to stop this video and I'll do the next example on the next video.